Hello class and welcome to lesson 6.5. So this is normal distribution day 2. So what I want you to do is take a look at these warm-ups, ladies and gentlemen, and we'll see what we can do. So notice folks, we've got our normal distribution curve here, which we learned last day. Remember that it's unimodal and symmetrical and asymptotic as well. Okay, we also learned some notation that we got to make sure we know, which talks about this. So it says the random variable x is normally distributed by, don't forget that when we take a look at this in general sense, it's normally distributed by the mu and the variance. Okay, so remember the mu stands for the mean, okay, and the sigma squared represents the variance. Okay. So if we want to find standard deviation, which is what we always do, that equals sigma, and to find that, it's the square root of the variance, which is 9. So the standard deviation equals 3. So what does that mean? To set up our graph, we know the mean is 10. So we put 10 right in the middle. And then to find our next bars, which means 1 standard deviation, 2 standard deviation, and 3, you keep adding or subtracting your standard deviation. So 3. So it's going to be 13, 16, and 19 as you go higher. And then don't forget to subtract on the way down. So 7, 4, and 1. All right. So given this probability distribution for A, we want the probability of greater than 10. So 10 is right here. So we shade, remember we shade that all in. Okay, so one way you could do is you could say, hey, I've got 34% plus the 13.5 plus the 2.23, etc., etc. But what you should be able to recognize, folks, is a shortcut here. Probability of x being greater than 10, guess what? If this is symmetrical, this means it's 0.5 or 50% because it's half of the graph, right? Okay? All right, because it includes even that little asymptotic 0.15% or whatever that was on the tail end. Okay? All right, let's take a look at the second example. So we need to go from 7, which is here, to the 13. So what you should recognize, hopefully, that this is 1 standard deviation away, above and below. Okay, and how much is the first standard deviation? Well, you should represent that it's 68% from your rule that we learned, 68, 95, 99.7. So proper communication, probability that x is greater than 7 but less than 13 equals 0.68 or 68%. Okay, because it's within 1 standard deviation, because those are the limits. All right, probability less than 7. Okay, so probability less than 7, you could do it a couple ways. Okay, so if we had this 7 and this is 1 and this was 4, okay, well, you could do one way. You could say, hey, these percentages, I know this is 13.5, I know this is 2.35, and I know this is 0.15. So that's one way you might do it. So probability when x is less than 7 equals 13.5 plus 2.35 plus 0.15, which equals 16%, because those are percentages. Now the other way you could do is you could take a look at what's left over and subtract what needs to be done. So another way of doing this is, you could say, or probability of x being less than 7. If you take 1, subtract the 0.68 that was up there, right? And then after that you divide by 2 because it's twice. You have to cover. So what that would do, folks, is that would cover this end and that end because you're subtracting the 68%, which is right here. Okay, and we divide by 2 because it's just one side. Okay, it's just another way of approaching at it. So you get 0.16 or 16%. Okay, either or method there works. All right, so now we're going to use the formula and a bit of the graphic calculator today to help us. All right, so today we will use the equation and the graphing calculators. So remember the buttons we're going to use in the menu, in the calc menu. Second, trace, and 7 to determine the area under the curve, which is the probability. Here is your normal distribution curve that we touched base on last day. Remember, you need to know the standard deviation and you need to know the mean. Okay? All right. So from yesterday, we have this equation. This you could plug in the graphing calculator. Okay, so again, plugging in the calculator is the most difficult task. You actually, in this case, need 7 sets of brackets to complete it. However, we're going to learn an easier way as we get going. But just to stay with me, folks, if you're properly plugging that equation in, you have 7 sets of brackets, and you'll find that if you do the data that lies between first standard deviations are going to be 6.1 to 10.3. 95% of the data is between 4 and 12.4. And 1.9 to 4.5. So what I'd like you to do, folks, is sub this equation in. Okay, press the second trace 7 button. Do your lower limit as 6.1, your upper limit as 10.3, and you're going to get close to 68%. It might be off a little bit just because of decimals and rounding. Okay, do the same for the second standard deviation, lower limit, upper limit, shade, and the probability should be 95%, and then do the third standard deviation. So lower limit, upper limit should give you a 99.7% probability. Now, if you need help with the window on that, let me help you out. So x min equals 0, x max equals 20, x scale equals 1. Okay, y min equals 0, y max equals 0.2, and remember your y scale is the one you got to work on here. It's going to equal 0.01. Okay, so plugging those in, you should get around those percentages. Okay, all right, let's take a look at another example. Okay, so this example is taken from your textbook, page 424. Giselle is 180 centimeters tall. In her high school, the boys' heights are normally distributed, so that tells you it's normal distribution, with a mean of 174, which is our mu. Okay, and a standard deviation of 6 centimeters. Okay. What is the probability that the first boy she meets at school is taller than she is? Okay. Well, first of all, we got to take a look at method 1, which is the paper and pencil method. So we're going to draw our standard deviation curve. Okay. And then from the middle, we know that the middle is 174. If we take the standard deviation and we subtract 1, so take 174, subtract 6, that equals 168. All right, so that's okay. So 168, that's our lower limit, right? So we need to know what's the probability, because that's how tall she is, right? So we need to figure out the probability of this. Well, hopefully you should recognize, folks, when we do this, that we've got 2 sections, half and then plus the 34. So probability that x is 168 equals 0.34, which is half of the 68%, plus the 0.5, which equals 0.84, or 84%. And don't forget, we haven't identified what x is in this question, so x is the height of the boy. Okay? All right, that's the paper and pencil method. Now we're going to learn how to use the graphing calculator with the equation, and I'm going to show you some other methods which get easier as we go. Please bear with me with this first equation. So go to y equals, and insert this. Make sure you've got the proper number of brackets. I think there's 7 total. Okay. And you can simply use and insert the delete buttons to help replace the mean and the standard deviation. So once you've got it in, for example, you only need to replace, if you have this left in from last day, it was this number and this number is the only one that you could insert and delete, and the other one should be there. All right. So, ladies and gentlemen, when we do this, okay, remember the mean is right here and the standard deviation is right there. We need to get a window set up. So for our window, let's make x min equal 150 because it's below our data. X max, let's make it 200 because we got to cover all the possible heights. X scale equals 10. That's fine if we go up by 10. Y min will equal 0. Y max equals 0.08, and Y scale, it's usually small, 0.01. All right, so plug that in, ladies and gentlemen. Okay, after you've done that, you then press your second trace and 7 button and your lower limit. So it asks for lower limit. Okay, that equals her height, which is 168. The upper limit has to be off the graph. So we're going to use an upper limit of 200. Okay, and then you press enter and your f at x dx answer should equal 0.84, which means, or 84%. Okay, so far we've got, I forgot my therefore statement up above, didn't I? Haha. Okay, so we'll put it one where in between here. So therefore, 84% chance of meeting a boy taller than her. All right, so ladies and gentlemen, hopefully you got that equation to go. Now we're going to move into an easier method. Okay, now an easier method is method number 3. Okay, and you're going to use what's called the normal PDF function. Please take a look at page 528 if you need help with this. Okay, it allows you to create the curve by entering in the notation of x, the mean, and the standard deviation. Okay, all right. So here's the number 1 thing we do. Go to y equals and clear the equation. Okay, then press second vars 1. Okay, then we are going to take a look at putting x in 164,6 and press enter, and then graph. Okay, okay, and hopefully you got the same result. Okay, and method 4 is probably the best and easiest one. Okay, so I like method 4, and this is called the shade normal, and it will graph and shade at the same time. Okay, so this is pretty cool. So you press second vars arrow over draw 1. Okay, don't forget to enter in lower limit, upper limit, okay, mean and standard deviation. Okay, and then closing bracket, and then that should help you get the answer. Okay, so try those out. Those are cool. Obviously, you need a graphing calculator to do this. Here's your homework, folks. Page 430, do number 1, and then first 2. I don't know what that means. We'll have to check that over when you do yours in class. Oh, just do the first 2, I think, in 1. Okay, and check number 2 out and number 8. Again, use a graphing calculator, folks. It's going to help you with this. Have a great day, and if you need any help, for sure, come and see me. Ciao, bella, au revoir, à demain.